This video is going to have a look at how to apply arithmetic sequences to be able to calculate straight line depreciation. Now, straight line depreciation is what we call depreciation when we're deducting the same amount from the value of the asset each year. So the value of the depreciation does not change over the life of the asset. So when I'm calculating straight line depreciation, I can start off with the general arithmetic rule. So Tn is equal to T1 plus n minus 1 times by d, and I can make a few adjustments. The first adjustment is that I'm starting off with my T0 value, which is the original value of the equipment. The first value in the sequence is going to be the value after 12 months. So I'm starting off with the original value, which is before the sequence actually starts. So it's going to be a T0 value. Because I'm using a T0 value, I don't need a minus 1 after the n. I can also, if I choose to, move the d in front of the n. And then because I'm depreciating, so I'm taking away value, it's not going to be a plus, it's going to be a minus. And then the last adjustment I can make, because I'm dealing with the value of equipment, I can use V instead of T. So after making those adjustments, my general rule for straight line depreciation becomes Vn is equal to V0 minus Dn. So that's the rule that I can use when I'm calculating straight line depreciation. So let's have a look at an example of how do we apply this rule and apply straight line depreciation to an arithmetic sequence. So in the example, we have a value of a machine that's being depreciated using flat rate depreciation at a value of 12% of its initial value every year. The initial value was originally $100,000, and it's starting off by asking us to set up a recurrence relation to display this information. So to be able to write or set up the recurrence relation, I need to find out what my D value is, my common difference, and that is going to be, in this case, 12% of the original value. So I need to go 100,000 times by 0.12, which is equal to $12,000. So my depreciation each year is going to be equal to $12,000. With our straight line depreciation questions, sometimes they'll tell you the amount, other times they will give you the percent and you have to calculate it yourself. So if you do need to calculate the depreciation yourself, it's going to be the flat line depreciation percent times by the original amount. So now that I have that D value, my difference value, I can go ahead and set up my recurrence relation. And to set it up, it's going to be my first term. So V0 is equal to 100,000. And then my next term in the sequence is going to equal to my current term minus 12,000 n. So V0 is equal to 100,000. Vn plus 1 is equal to Vn minus 12,000 n. Now I can use the same information to be able to write the rule, and the rule is going to be Vn is equal to 100,000 minus 12,000 n. So now that I've set up the recurrence relation and I've got the rule, I can go ahead and find the value of the machine after 5 years, and I'm going to substitute n equals 5 into my rule to be able to come up with that value. So V5 is going to equal to 100,000 minus 12,000 times by 5, which equals to $40,000. So finishing off by answering the question, the value of the equipment is $40,000 after 5 years. So that's an example of how we can apply straight line depreciation or flat rate depreciation to an arithmetic sequence.